All right, you guys, this is part two. We're gonna look at this kinetic energy square relationship thing. So let's look at a square relationship on a graph. So what pattern do we see when we make a square relationship on a graph? You see this curve shape. Now that's important. So think about your velocity here. If you started with 5 meters per second of speed and you doubled your velocity, if you doubled your velocity to 10, what happens to your amount of energy? You start with 10 joules and you end up with 40 joules of energy. So what happened to your kinetic energy when you doubled your velocity is you quadrupled your kinetic energy. So think about that if you're ever like driving a car. If you double your speed, think about how much more damage you can do. If you go from 25 miles an hour to 50 miles an hour, you are able to do 4 times the amount of damage, and that's it's a really important fact, you guys. So think about your velocity, especially when you're operating a vehicle when you guys get licenses. I'm gonna write this in a different color, and I'll go the other direction. So like let's say you slow down. You start with 10 meters per second of velocity, and you end up with 5 meters per second of velocity. So I've changed by a factor of times 1/2. So my factor is 1/2. And how much has my kinetic energy changed by? I've changed by a factor from 40 to 10. I've changed by a factor of times 1/4. So look at how those numbers, you can kind of see how 1/2 squared is 1/4. And squaring times 2 is times 4. So what pattern does a square relationship make on a data table? Let's take a look. So we have velocity on one axis and kinetic energy on the other. If you double your velocity, you go from 2 to 4. So if you notice, there's this pattern. The velocity is changing by a factor of 2. So it's doubling. The kinetic energy is changing by a factor of 4. So it's quadrupling. Times 4. There was supposed to be a decimal there. So think about this. So 2, if velocity, let me write this in red. If velocity changes by a factor of 2, then a square relationship tells us that the kinetic energy will change by that factor 2 squared. And remember, when we square something, we multiply it by itself. Cool, so that's what we mean when we say a square relationship. Last little bit here. And this I wrote wrong. A square relationship. If one variable changes by a factor, the other variable changes by that factor squared. When we say squared, that means that the factor is multiplied by itself. Okay? For example, 2 times 2 equals 4. 1/3 times 1/3 equals 1/9. You could do whatever. You could 0.5 times 0.5 equals 0.25. That's if something were to change by a factor of 0.5, which is the same as saying times 1/2. Whoop. 1/2 squared. 1/2 squared is the same as 1/2 times 1/2, which equals 1/4. These two are the same thing. One's just in decimal form and one's in fractional form. Okay, so we got a little example. If variable a and b have a square relationship, then what is the new value of b? So let's look. Variable a. So variable a starts with 6 units and ends with 2 units. So what factor did we multiply 6 by to go from 6 to 2? So how do we figure that out? Well, you can use simple algebra. 6x equals 2. Divide both sides by 6, and you get x equals 2 over 6, which is the same as 1/3. I just went through that kind of quick, but I just did a little simple dividing by both sides. Whatever you do one side, you do the other. Get rid of the 6 to isolate the variable and end up with 1/3. So what happened here? So 6 multiplied by 1/3 equals 2. So let's look at the definition again. If one variable changes by a factor, the other variable changes by that factor squared. So what was the factor that variable A was changed by? It was 1/3. So what is 1/3 squared? I'll write it in blue right here. So 1/3 squared is the same as 1/3 times 1/3, which equals 1/9. And that means that the other variable is going to change by a factor of 1/9. 81 times 1/9 equals 9.0. Now, this was a little change from your sheet, so you can make your little adjustment. You can see I edited that number right there. So that is a square relationship. I'll do one more, and then you guys do the last one on your own. So now we have one that has to do with our physics. If an object's velocity changes from 4.0 meters per second to 16 meters per second, how will its kinetic energy change? Okay, so we know that kinetic energy equals 1/2 mv squared. And the only reason I wrote that relationship is to remind us that kinetic energy and velocity have a square relationship. Kinetic energy is directly related to the square of the velocity. So if velocity changes, kinetic energy is going to change by that same factor squared. So velocity, we start with 4 and we end with 16. So what factor did the initial velocity change by? Well, 4 times x equals 16. What's x? Well, 4, you probably just intuitively know that 4 times 4 equals 16. So if velocity was multiplied by 4, then kinetic energy will change by that factor 4 squared, and 4 times 4 equals 16. So kinetic energy will change by a factor of 16. 2 times 16 equals 32 joules. Okay, so if velocity quadruples, kinetic energy is multiplied by 16 or changes by a factor of 16. That's how you'd say that. So this last one here, I want you to try on your own. If an object's velocity decreases from 4 to 2, how will its kinetic energy change? So you see its velocity changed from 4 to 2, and that means that it changed by a certain factor. It's multiplied by something. So what's the new kinetic energy? You have to take whatever factor you find for velocity. You got to square it. Good luck, young physics geniuses. That's the square relationship. So as a whole, kinetic energy has got these little different parts. Think about the mass. Think of that direct relationship. Think about the kinetic energy and that square relationship. This here, this 1/2 thing, that's just a coefficient and it doesn't change. You don't have to really worry about the 1/2 when you're talking about cause and effect and the changes. But if you're calculating kinetic energy, you need to have that 1/2 there in your calculations to get the right amount of joules.